All right, hello everyone. Hope you are all good. Welcome to another session of Streaming School. Unfortunately, Leon couldn't be here for this session, but we do have Mr. Michael Gard. If I can show you on the
unfortunately,
screen.
Yeah, he'll kill me when he watches this back, but don't worry about that.
No, it's all good, all good. Mike Scott, how are you?
Yeah, I'm really good. Everything's good.
Good.
Just enjoying this. Still enjoying this strange time, but yeah.
Yeah. All right, cool. You
I'm
ready?
all good. Yeah. If you want to make a start, can do.
Yeah, cool. I have shared your screen. Right. Over to you.
Nice one. Thank you. Okay, guys. So you may remember from our last lesson in physics, the last time that I was presenting to you guys, we were looking at something called static electricity. And just to give you a recap, just to reinforce really what was learned, we spoke about what happens when two insulators rub together. There's a transfer of electrons, and when there's a transfer of electrons, it leads to one insulator becoming positively charged and another insulator becoming negatively charged. And what we want to kind of look at today is not this idea of static electricity, but we want to build on that now for us to look at electric current. You should know, as a GCSE student, the definition of this term electric current. And when we talk about electric current, it quite simply means the flow of charge. Electrons carry this charge. They carry this charge around a circuit. Now, there are a few component symbols that you guys will definitely need to know for your GCSE. You should be able to identify these symbols. You should be able to tell me the name of these symbols, and you should also be able to use them in your own circuit diagrams. So, for example, we have a component symbol like this. I'm just going to draw a few of the key ones for you guys, because we are going to use these throughout this lesson today. Okay, so here are some of the main circuit symbols that, as a GCSE student, you should be quite accustomed to using, and you should be able to see these and identify exactly what they are straight away. So we'll start off with this one at the top, where we have a battery, we have a cell, we have an ammeter, we have a voltmeter, we have what's known as a fixed resistor. We have a thermistor. We have an LDR, and that just stands for a light depending resistor. We have a diode, and we have a bulb. And what you should be able to do, guys, is you should be able to look at any given circuit, and you could be asked to draw, oops, went a bit wrong there. You could be asked to draw a circuit including these different components. So just to start off really with where we're going to be going today, I want you to take a look at this circuit for me. You can see that we've got a battery and we have a bulb. And so we'll call this one circuit 1. And then I also want you to take a look at circuit number 2, which is right here. Now, in both of these circuits, the light bulb would not turn on. I'm going to give you 30 seconds just to have a think about why in both of these circuits would the light bulb not turn on. In other words, why won't the charge be able to flow? Because components can only work once charge flows. So just take a look at these two diagrams. Again, I'll just give you 30 seconds just to have a think about why the light bulb in each circuit would not actually work. Okay, so hopefully after looking at circuit number 1, at this one, you will notice that here there is a break or a gap in the circuit. And it's that gap or that break in the circuit that won't allow the charge to flow around this circuit. So in order for charge to flow, you must have a complete circuit. There can't be any gaps or any breaks in the circuit in order for it to work. Now, if we look at circuit number 2, again, this light bulb won't switch on. It will not be able to turn on. Again, the reason for that, you'll notice that there's no gaps in this circuit, but what is missing, there is no battery. There is no source of power, no potential difference. And we'll look at what that word means in future lessons. So in both of these circuits, the light bulb would not have turned on how they initially were. And that's a good reminder that you have to have a complete circuit and you also need a battery. So in order for current to flow or for this charge to flow, you must have a complete circuit and you must have a battery. Now, what we're going to spend the rest of this lesson on is we're going to take a look at what are the different types of circuit. So there are 2 circuits that you are expected to know about at GCSE. You should be able to spot these circuits and you should be able to understand what is happening to the charge in each circuit. So let's take a look at the simplest circuit, which we call a series circuit. Okay. Now, a series circuit just means that all of the components are in one loop. Okay. So you can see here that all of the components of this circuit, they are all in one loop. In other words, you can take your finger and you can go around this circuit without ever kind of taking your finger off the circuit. So everything is in just one loop in a series circuit. Now, I'm going to put next to the ammeter, ammeters are used to measure current. Next to each ammeter, I'm going to put a reading. So I'm going to put 2 amps here and 2 amps here. Now, what this tells us is that in a series circuit, current stays the same. Now, remember what we said about current? Current is just the flow of charge. So within this series circuit, the flow of charge will be the same at any point in that circuit. So for example, I could put an ammeter at the top here. I could put an ammeter here, and it would still read 2 amps. And this one would still read 2 amps, because current does not change in a series circuit. We've got to look at one other factor, and that factor is called potential difference. Now, potential difference, it basically means how much energy is transferred by each coulomb of charge, or by each measurement of charge. Now, we measure potential difference in a unit called the volt. Now, let's just say, for example, that the battery at the top here, let's say that this is a 9-volt battery. Okay, let's say this is a 9-volt battery. Well, what could happen, guys, is if I was to put a voltmeter across this light bulb here, and if I was to put a voltmeter across this light bulb here, okay, voltmeters measure potential difference. Well, what you may observe, especially if these bulbs are identical, is the potential difference across this bulb could be 4.5 volts, and the potential difference across this identical bulb would also be 4.5 volts. Now, hopefully what you can see from this diagram here is that potential difference in a series circuit splits up. So current stayed the same, but potential difference split up, it divided. Now we're going to compare this to I'm just going to rub out these components now. We're just going to compare this to a parallel circuit. Okay, we're going to compare this to a parallel. Oh, another, I suppose, an interesting point just to add here, guys, is that in a series circuit, let's just say, for example, that this light bulb here broke. Well, if this light bulb here broke, it would cause this light bulb here, the second one, that one would turn off straight away. And the reason that that light bulb would turn off is because you've now created a gap in the circuit. And remember, in order for charge to flow, it has to be complete. So let's just compare this to a parallel circuit. And hopefully you guys can spot here that when we talk about a parallel circuit, what that actually means is a circuit with more than one loop. There you go. So within a parallel circuit, notice, look, a series circuit, charge can only flow one way around that circuit. But in a parallel circuit, the charge can either go through that loop or the charge can go through that loop. So let's just have a look at the rules in terms of current and potential difference, like what happens in a parallel circuit. So I'm just going to undo what I did before. There you go. Okay, so let's say on this ammeter here, we got a reading of 3 amps. Okay, that's the current coming out of the battery here. Now, once that current gets to this junction here, depending on the resistance of the light bulb, the current is going to split up. Now, if these light bulbs are identical, just how they were in our series circuit, then we're going to get 1.5 amps of current going through this branch. And we're also going to get 1.5 amps of current going through this branch here. Hopefully you guys can see here that what's happened is the current has split up. So in a parallel circuit, we can say that current splits up. Now, again, and I'll close with this one. If we were to put a voltmeter across this light bulb, and we were to put a voltmeter across this light bulb here, again, let's say that our battery at the top, just for consistency, let's say this is also 9 volts, just as before. So we've got a 9-volt battery connected in a parallel circuit. You could be asked in your exam, well, what would the reading on the voltmeters be? Now, there's a common rule that you have to remember for parallel circuits, and that rule is that potential difference it stays the same. It doesn't change. So the reading on this voltmeter here would be 9 volts, and the voltmeter reading across this light bulb would also be 9 volts. Let me put it at the top here, 9 volts. Now, what you guys should be able to spot is that in terms of current and potential difference, a series circuit and a parallel circuit are completely opposite. In a series circuit, current stays the same, but in a parallel circuit, current splits up, and potential difference in a series circuit splits up, but in a parallel circuit, it stays the same. Just a final scenario here. Just how we said in our series circuit before, if one of the light bulbs broke, it would cause the other light bulb to turn off. Well, can you predict what would happen if this light bulb broke? And hopefully you guys have predicted that this light bulb here, it would stay on. This light bulb would stay on because remember, the current splits up at this junction right here. And in actual fact, this is how Christmas lights are wired. So when you put your lights around the Christmas tree, nowadays the lights are wired in parallel. And what that means is that if one of those Christmas lights break, it won't cause all of them to turn off. I remember when I was younger, and my mum used to do the Christmas tree. If one of the light bulbs, I'll just show you here, if one of the light bulbs blown, or if one of the light bulbs broke, if one of them broke, it would cause all of the bulbs to turn off. So the old Christmas lights are wired in series, whereas the newer Christmas lights are wired in parallel. So if one bulb breaks, it doesn't cause all of them to turn off. And I think there are some questions, guys, for you guys on series and parallel circuits. So I'll hand over back to our presenters of the day.
All right, thank you so much.
That is not a problem.
Me and Leon always say that we love watching your lessons. Like,
what's that, sorry?
Me and Leon always say that we love watching your lessons.
Yeah, it is. I'm gonna release a book where I just talk, make people go to sleep.
Do it. No, seriously, it's not a joke.
Yeah.
Every time we're like, yeah, we're ready for his lesson. But thank you so much.
I'm just gonna release a book where I just read an audio book. I just read.
Do it.
Hypnosis by Mike.
Exactly. That's it.
Oh man. All right. Well,
right. So just let me know, Nish, if you've got the plan for tomorrow.
I will. I do have it. I did check. I do have it
later on. Yeah.
Yeah.
All right. Take care, guys.
Thanks.
Yeah.
Bye.
Take care. See you in a bit, Mike. Take care, Nisha. Bye.
Bye. That was your first lesson sitting in with Mike. How was it?
It was good. God, I tell you, I remember Christmas lights kind of just turning off and then having to unwire them from around the tree and try and work out which bulb it was. So I'm so glad we now work in parallel rather than series when it comes to our Christmas decorations.
Always helpful. All right, cool. I will let you lead out today.
Thank you. And so hopefully you guys can see the tasks for science. Is that correct now, Nish?
Yeah.
Fantastic. So as Mike was saying, the task that you may wish to undertake is to establish whether your house is wired in series or in parallel. And if you want to look at this particular task or any of the optional tasks, they are available for free, as you know, on the Streaming School site. And the code is me123. It's on the descriptions on the bottom of our various social pages. And yeah, we look forward to seeing you in our next session, which is Spanish with Alex.
Yes. All right. See you in a bit. See you in around 20 minutes.
Thank you.